So I will be talking about Lab 2. And first of all, let's introduce the table of contents. So obviously I'm going to introduce the lab and its purpose. And we're going to talk about the equations that we're going to use in this lab, and then our observed data. And then we're going to be talking about the code and what's exactly used to compute our desired data, how the code is used. And then we're going to be talking about questions, what ifs, comparing graphs, and our summary. And so, what is the purpose of this lab? So, we're going to be applying concepts of gravity and using drag force to real life concept conditions. So, we obviously ask ourselves, what's the point of studying this if we're not going to apply it to real life? So, the thing here is that we're actually applying it to real life and studying it, and we're going to see how these concepts that we've used and learned about gravity and drag force, we're going to talk about how they affect falling objects and their positions. And so our initial condition here is that initial velocity is zero as we start from rest, and the force applied by our hand, which is when the ball leaves, and the force of weight are equal in opposite directions. So that's the using the law of reciprocity in Newton's second law. And so yeah, pretty much you can see in this model that's pretty much how those two forces look like. And it's really important to note that when dropping the ball, the unit vector becomes 0 minus 1 because it falls down by the y-axis. And so these are fundamental formulas we need to have in mind. So these are used from lab 1, and it's Newton's second law, and because we're computing net and velocity, so we're going to be using the position of date formula because we're going to be looking at the change in position of the object, and then of course if g and 1 and 2, and g using the velocity due to gravity, the acceleration due to gravity, and if g equal to m times m multiplied by g, which we pretty much are very familiar with, and then the drag force, which is going to be our last model, and we're going to be seeing how the drag force affects our position. And so this is our video we're going to be looking at. So this is the hand that leaves the hand from which the ball leaves, and you can see this graph here shows that there's obviously some error to it, and there's not constant velocity obviously. And these are the values that our tracker allowed us to get from the video, and this graph is quite uneven as you see at the end. So this pretty much shows that there's probably like some human error as expected to it. And yeah, you can pretty much see that it's going pretty naturally, and this is our code, and this is where we're using our formulas that were shown in the previous slides. So this is F Earth, obviously acceleration due to gravity. VF is here. This is how we compute the velocity, and this is our formula for the position, and then this is Fg equal to m times m multiplied by g. And so as we use the code, this is pretty much the more like less flawed computational model. These are the values observed. And as we compare these, we see that this goes perfectly down the computational model. And the first one, which is contains human errors, shows that there's something slowing down the bow here. And as expected, this will be the drag force. And so we need to edit our code accordingly to the drag force, which is what we do. And this is our computational model with the drag force. And as we see, the initial video and the newest model, they pretty much end at the same place, which shows that there is in fact drag force here. And so which models, if any, predict terminal velocity? The one with the drag force, obviously. As if there was no drag force, the object will be speeding infinitely. And so terminal velocity shows that at some point the change of v is equal to 0 because v becomes constant as it cannot accelerate more. And if the object was initially thrown downward, the as we see in this formula, v would just be larger, so these would cancel out quickly and more quickly. So what will happen is terminal velocity will just be reached faster